So the idea is to finish off Java 1 with a little bit of Groovy. And this is the slideless talk of the day. There's not even an introductory slide, not even a slide with my name on. So only code that says my name from Groovy. I'm absolutely fine to code on stage whatever you would like me to code. Of course, I have a plan. And if you don't steer me otherwise, I'm going to show you something that I consider is important for a Groovy professional. But if you would like to see anything, don't raise your hand, even just scream into the room. That's absolutely fine for me. We just spend an hour of fun. And I may do some philosophical remarks along the way. And if you think that's okay, then it's all fine. And if not, then we part as friends. Good. We play this very low key here. Is everybody fine? Okay. Good. I see a lot of nodding. Who has done any Groovy before? Who has seen any Groovy? Ah, that's almost everybody. Thank you. That is fine. A few years ago, when I asked this question, I got like 10%, and then a few years later, half of the audience. And I always said, we have to work on that, but now it kind of finished. Good to see that. Awesome. So since we have more than a quality group here, like more than 50 people, I'd say, and all Groovy and Java enthusiasts in the room. What would be a good place to start? So what we need to begin with is Groovy. The latest Groovy, possibly. And since half an hour ago, there's a new version of Groovy. It's Groovy 2.05. And I haven't even installed it yet. Right? Let's install it. So I wouldn't install Groovy without the help of Groovy. Of course, I have already some Groovy in my thing here. So, go back, close the console, and say I'd like to install Groovy. What do I have to do? Well, I have to find the right download link, and I'd like to have the binary distribution and the source distribution and the documentation, and they need to be unzipped, and I have to change the execution modifier on the binary script maybe, and they need to be in a certain structure such that whenever I refer to it from my IDE, I'd like to have the full support with source and documentation and so on. Okay, I have to do this every time when there's a new Groovy. So therefore, I made myself a script in Groovy. It's called install. I can run it from Groovy, install. I have forgotten the parameters. I have forgotten the command line arguments. So yeah, it will probably say, I'm not even in the right directory. Sorry, cd here. So Groovy install. What does it say? It tells me, hey, you forgot to sudo your root rights, right? And you should say sudo Groovy install and then the version number. Okay, thank you. Sudo Groovy install 2.05. Password. That's because this will be unzipped into a directory where only root has access rights. That's going to get it from the web. May take a little over this online connectivity thing here. Meanwhile, let's download this, and that takes a bit of time. But I don't have to do it manually. I can do something else in between, which is all the purpose of automation. You'd like to do this. You'd like to do something else meanwhile. And what I would like to do is, of course, show you the install script. What is it doing? Otherwise, there's no point in doing this. So, Der König, and there somewhere is install.groovy. Do I see this? It starts with an I, huh? So, was text made. This is my install script. Well, is it visible from the back? Does that give me some nodding or shaking? Almost. Okay.
A little bigger.
Boop, 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 boop. Like so? Good. So what is it doing? First, it tells me if the amount of arguments that have been passed in is not equals 1. It prints the usage statement and exits. Right? This sounds like a very small hint or tip, as we say in Germany. But I would actually advise for all the Groovy scripts that you're doing for this little automation stuff, that's a very good thing to have because it relieves you from remembering all your command line arguments. Good. Argument 1 is the version. There is an installation directory where this goes to. The download base is below here. And then there's 3 URLs to fetch for the binary, the source, and the documentation. And then I'm using, for the actual download, the end builder. Who has ever seen the end builder before? Give a show of hands, like more than half. It gives you all the capabilities of end with the standard Groovy distribution. For example, the get task, the unzip task, the delete task, and the chmod task, change modification task. That's really cool. So for all the URLs that I have, I fetch them, I unzip them, and after unzipping, I delete the zip file. I'd like to keep things clean. Right? And then I'm going through the install directory through all the respective Groovy version bin files here, Groovy. It's only one of those. I go through all the files and I pick the ones that do not contain a dot. Those are the starter files on Mac. And I change the modification to 775, which gives me execution rights for then the Groovy script and so on. Makes sense, right? I haven't looked at this file at least for over a year. But still I can very easily explain what it does. You know, I can understand for myself what it does, which is a major difference from the automation scripts that I had before in Perl and Bash and so on. No, pretty easy to do. Here are we? Where are we? Deleting? Where? Are we here? Here we are. Good. Now I'd like to set my environment for Groovy execution to the new version. First I have to check whether it's there, and for checking I have a Groovy script which is called Senf. Senf is the German word for mustard, but yeah, anyway, it's also for setenv, so to speak. Okay, usage Groovy Senf. Almost. It says, well, if you go with Senf over here, you either have to say Java or Groovy or Rails or Griffon, since I'm managing a number of different environments here. So how about Senf Groovy? So these are my current Groovy versions that I have installed, and of course I have a number of them since I have to check against all different kinds of bugs against different versions of Groovy. So let's set, what happens if I would set the environment to Groovy 2.05? What would happen? At the moment it would actually execute the following statements against my shell, which is export Groovy home to the new one over here, and exporting a new path. And the trick is that in this path variable, the 2.05 version appears only once, right? There is no second Groovy version which is kind of hidden because of the sequence that you have in your path variables. You probably know the problems that come up with those approaches. So that means that this set environment script first cleans the class path before, first cleans the path before reconstructing it. So if I would like to execute this, these statements, I put them in backticks. Senf Groovy 205, backtick. Here we go, executed. Which Groovy? 205. Now it's fine. Groovy minus version 205, and as you see, I'm on the latest Java 7 early access. But with these same commands, I can also change my Java version, my Gradle's version, Griffin version, what have you, and can test any kind of combination where a possible bug may occur that I have to reconstruct. So how does the Zenf look like? That environment. Made Zenf Groovy. Well, here it is. Command Shift plus. Now let's see whether I can understand and explain it. The allowed programs, Java, Groovy, Gradle, Griffin. If the argument size is not what I expect, then I print the usage statement. Otherwise, the program is the first argument. The location that I use, the directory where I expect things to be, but it's exactly analogous to where I've installed with the other script. And if I don't give any version number, then it will print me the version numbers which are available by simply going to the respective location, listing all the files, grabbing from the list of files the toString representation of a file for ignore case of the respective program. Return. Finished. Otherwise, the version number is the second argument. And if that second argument is Java, this lives, because of the installation directories in Mac, this lives in a different directory. I have to go here. Good. So the binary path that I'd like to say should now is about to contain this location and the bin directory below it. I first make sure that this path really exists. That's because I'm defensive. And here comes all the rest. Maybe this may be a bit difficult to see from the back if it's so low on the projector and you're looking at the back of the head of the one before you. That's the case in the back, yeah? Okay. Yeah, here you go. We are exporting. We just println to the console. That's a cool trick. Just println the statement that is required, and then we're cleaning the path like so. From the system environment, we get the path variable. We are tokenized on the colon, which is the path delimiter character on Mac. Now we have a list of all the elements in the path. We grab through the list and we for all the elements that do not contain our program in the two lowercase version. That means we have actually we have removed the old versions this way, and then we are joining again with a colon character. There's a slight duplication in the code. Okay. I tried to remove the duplication, but it wasn't easier to read after the refactoring, so I left it in again. And then we print on the export statement that it was. Pretty easy. The groovy kung fu point to take away is it makes your life much easier if you can automate this kind of tasks along the way. How often do I have to manually setting this kind of stuff? So, yeah. If you like it, make the one yourself that you need, or send me an email and I'll send you the code. No problem. Email address is easy to find. All the pharmaceutical companies on this planet have found my email address. Now what is my email address? Zip. Should be there. Dirk.Koenig GNU.com. If you'd like to follow me on Twitter, that is @Mitty. For some reason, my command line doesn't understand my email address, so okay. So that's all fine. Drop me a mail, and I'll respond immediately. I have been asked to put this on GitHub, but since it contains private information where things are on my machine, I was a bit reluctant of doing that. I may be a bit paranoid about that. Okay. Now, we do have this nice Groovy 205, and we would like to start with, let's say, some real good Groovy project as of now. What do we have to do? Oh, it should be a real project. It should be something, you know, Maven-like or so. Of course, in the Groovy ecosystem, we would rather prefer using Gradle. And to make this possible, let me cd to desktop jar1. I'll put this down below here. And let's construct a build Gradle, which is the build file for the build automation that we're going to need. Made build Gradle. And here is all the code that you have to write. Apply. And I have a standard that I'd like to use, a default Gradle script that lives in my root directory. So I say from, give it /default.gradle. Command S, Command W, going back to the console, saying Gradle, tasks. What task do I have? Can I do something over here? It's loading. Build successful, and then I can, for example, make deers. I can have the Gradle wrap. Who has ever used Gradle before? Please show of hands. 20%? Maybe a little less. If you haven't looked at Gradle before, give it a look. It makes a lot of sense. It is like the best of Ant and the best of Maven combined. So I'd like to, sorry, that was the wrong direction. I'd like to create all the directories that I need for my project. So Gradle, make deers. If I'm a slow typer, I can say MD. It will pick up the right thing. Loading it, doing it, giving some output, and now I'm open the directory to see the structure that it has created. Here's the Gradle subdirectory. That was all the old stuff that was in there. This is the file that we have added, which contains one line. But we have a source, and there's a source main, and there's a source main Groovy, and a source main Java, source main resources, which are at the moment empty, right? But this is the structure that you know from Maven. But instead of doing it manually, we do it automatically, which is, as you see, the running joke, the binding theme for the first half of the talk. Do some automation. Now, so what is in here? How does default Gradle look like? Mate/default Gradle. This looks like so. And I have to do this a little bit bigger. Apply plugin Groovy, apply plugin idea. Please give us, if we have something which doesn't come from Maven, which is not in the repository, I'd like to have jar files in the lib directory below me. Yeah, that would be good. Using per standard Groovy 2.0. We could change that to Groovy 2.05. Yeah, should do that. Command S. Saving it. I'm changing the default, and all my Gradle scripts that are based on the default will immediately use it. Right? Here's a make directories. Gradle has a very rich API that it exposes to the outside. Not only does it have a project object model, it gives you an API for what is in your project. For example, it has something called source sets, right? It has source sets for the main sources and for the test sources. And this is all the sources that we would like to combine. We go through all the sources, through all their source directories. We flattened them out because it was lists and lists. And then we go through all the source directories that are required from Groovy and Java. We're printing out, and this println automatically issues a log statement. It doesn't really print directly. It is intercepted and it's logging on the info level and saying, I'm making the source dir, and then we just call the API on the file, right? This is Java API, make this on a file. And there also is a wrapper that we can use and so on. Good. So that's pretty much it. If you want to have the file, send me an email. I'll pass it. Oh, this is actually on GitHub. If you're looking on GitHub, that's somewhere there. It's in a what they call gist or what they call it. Yeah. You'll find it. Good, here we go. So I'd like to add one line to my build Gradle. Where was it? Here. And that is, I'd like to create idea files. I cannot create NetBeans structures yet from here. I'm not quite sure. But I can apply.
But NetBeans can open a Gradle project that recognizes
okay.
the Gradle extension if you install
Cool.
the Gradle plugin.
Absolutely fine. So there's multiple ways of integrating what we have done here with IDEs, and thanks to Gert-Jan. In NetBeans, when you create a new project and you point it to a directory that contains a Gradle file, it will recognize it and pull in all the dependencies automatically. And same with some others. But you can also say apply plugin, and that is idea. Command S, and going back to the command line, I can say Gradle idea, which is what I'm going to do for today. Loading, building, making idea modules, making an idea workspace, cap. Oh, come on, cap. ls. Now we have a project file here for Java 1.12, which is supposed to be our application name. I guess I can open it there. Idea. If I'm not mistaken, I can directly start it like so. It may open in the. Oh yeah, it opened in an invisible state. So what we have here is the Java 1 thing that we have. There was a ScreenFlow thing below it. We have all our sources. We have the external libraries. You see Java 1.7. We should actually see Groovy as well. Isn't it in there? Source main Groovy. And I'm quite surprised that Groovy doesn't appear over here. We don't have the Groovy 205 library yet installed, but well, okay. I'll do this manually for the moment. Give it some, yeah, therefore, that was not available yet. We do this differently. We do this, remove this for the moment, and adding a different version of Groovy, since I haven't created the library yet. Okay, fine for the moment. Good, here you go. There we have it. And create a new Groovy script. I'll enhance the font size in a minute. And the name is Java 1. Okay. Here you go. Of course, you would like to see something running. You deserve it. Println hello, jar1, jar1, Control Shift F10. And skew this a little so visible from the back. Okay, good. So this has been an exercise in 5 minutes for setting up a new project. You're absolutely fully fine to go with all the dependencies that you want to have and start Groovy hacking. What could we possibly do in Groovy, right? Here comes the Groovy code. Who has been in the community keynote this morning? Oh, a little more than half. All the other ones were asleep. Who has not gone to the keynote? Oh, okay, the other ones are asleep. Good. There was, again, an introduction of a really cool project, Sumatra, which is, I guess, geographically close to Java somewhere. And it's all about using the graphics pipeline and the GPU for parallelism and so on. That's all fine. Now, parallelism, parallel computing is really important, and we wouldn't want to leverage all the multi-core capabilities of our machine until maybe then Java 9 or later, right? So with Groovy, you can very easily parallelize your code. For example, what do we do in Groovy? Let's do some easy task like having a list. Let's say 1, 2, 3, 4, 5. No, I don't type that. I say 1 until 5, which is a range to list. Now I have a list, right? Good. I'd like to compute the square numbers from 1 to 5. So 1, 4, 9, 16, 25, I hope, if I'm not mistaken. So how do you do this? In Groovy, of course, you simply say list squares equals list dot collect. Can I get some code completion, please? No? Bad. Collect it times it, for example. If we say, if you're using the standard it for the parameter that comes in the closure, or otherwise give it a name, n, and then using n times n. No surprise here, I guess, for most of you. That's true. And print the squares. Good. Well, seems okay. Good. This is a typical task that could easily be parallelized, right? So every computation in here is totally independent of any other selection outside. So we could easily parallelize the computation of squares. By the way, doing this for performance reason at this point is silly because the sequential version will always be faster. For this little piece of code, you have to have bigger chunks of code for really seeing the performance improvement. But let's say only for the sake of the argument that has been brought forward this morning, how difficult it is currently to do this in a parallel fashion. So let's say parallel. Collect parallel. Now, collect parallel is not known. Oh, yeah. Could split it into declaration and assignment, thanks. collect parallel is not known by default on a list. Only when you're putting that argument in a context where you have a thread pool where GPars that comes with Groovy can actually draw new threads from the thread pool. So we need a method that's called with pool that takes some closure in which collect parallel is known. Does it give me almost? For some reason, I normally get support here for doing the static thing. So I need comes from GPars pool. Yeah, with pool and GPars pool is I'd like to import it. Add library to author to class path. That would be interesting. Yes, please. Add import on demand with pool. It has created it. Yeah, sorry. The static method. I was somehow mistaken on the support here. Something has changed. Well, here you go. So the logic of computation stays pretty much the same. We only changed one method name. Now, if we run it again, it is all parallel. Okay, you don't believe me. I see it in your eyes, right? You don't believe me. Now let's try. So let's say that in the collect parallel, we print in the current thread, for example, right? Println thread dot current thread. What you may see, I'm going to explain it for the people in the back. So what you see is a fork join pool, and it's the first fork join pool, which has multiple worker threads, 5, 3, 4, 1, 2, with the same priority and in the thread group main. So it's actually it's using multiple threads. If we wouldn't have the collect parallel but only collect, then this has all the same thread in the main thread. So we have collect. We can use collect parallel, or we could just change the list a little and say the list make concurrent. Current. And then we can use the normal collect, right, as we had before, which is also interesting because it means when the code lives somewhere in a method that simply takes a list and does something with it, we can pass it a list which knows for itself how to make itself concurrency friendly, right?
Since you're making a new list or whatnot, does it do anything to put the order of the list back into the same place?
Okay, so here comes a very good comment on this. And I take this as, isn't this trivial anyway to do with threads? And then the question comes up, not quite, because if I fire up new threads, by the way, you should also always use a thread pool, yeah. And most people don't do it if they try. But then I have this issue that I can easily compute the squares, maybe in parallel, but then how do I put them together correctly in a new list? And the new list, doesn't this need to be a synchronized list because I'm adding things concurrently? And how's that done correctly? And how do I make sure that the sequence is not random, right? Collect parallel, the implementation of collect parallel takes full care of that. It relieves you from all the work. More strictly speaking, you cannot do it wrong. You cannot do it wrong in the sense of you cannot mess up with the concurrency scheme that is used here, the fixed concurrency scheme. If you'd like to do this with standard Java means, I know only few Java developers with more than 10 years of experience that would really get it right. I would say from 100 people, from 100 such developers, maybe one would get it right in the average. As it happens, just 2 weeks ago, I ran a Groovy course in London with a group of people that were totally newbies. They knew a little bit of Java, but no Groovy whatsoever. And we made this exercise. I explained how to use it, and we made an exercise for parallel computing with total newbies. And all of them, 100% of the class, got the exercise right. Right? This is amazing. Right? Simply because the API is now so much easier to use and doesn't give you much opportunity to get it wrong in the first place. Right?
Question?
Yes, please.
Could you enforce a random order of the resulting kind of square list by, let's say, adding a random sleeve inside the computation?
Oh, let's do the question was, if we would do, is this kind of time dependent and by accident that we have the right ordering? If we would do a random sleep in here, now we go into a concurrency anti-pattern, right? Okay, but I'm gonna give you a philosophical explanation of that. Good. So what we do now is what you should never do in concurrency. So let's do sleep. And we're sleeping math.random. What is it? Isn't there a next? There comes a double, and we give it times 1 second, right? Okay, so that we have then. Oh, that's for 3 seconds or so. We have some random value between what this returns is between 0 and 1, and we make it between 0 and 3 seconds. Is that okay? Good. So let's try. Does it? Did I do something wrong? Java 1 sleep. Sleep. Oh, this should be an integer, right? Times 3000 gives back a double. Is that correct? We have to put this into an int. I do it in not so groovy way, more Java way. Int, yes, thanks. I do it the Java way and I do it wrong. Of course, good. 1, 2, 3, 4. Now it takes a little. Seems to have worked. Now the next anti-pattern. Try again. Maybe we have a different result next time. This is another anti-pattern. Right? So let's first fix the code, because this was ugly. Well, I can actually spare the. I'm gonna sleep, and of course, when I have a double and I'd like to have a 2 integer, there's a 2 integer in Groovy. So that's much better. Good. Now, okay, leave that away. So professor raises his finger, right? Never. Here comes the anti-patterns for parallel programming. Throwing in random sleeps at certain pieces in order to evaluate whether your code is concurrency safe or not will not give you the right feedback. This, you will have random results, and but what does it tell you? You may see the error, okay, but even if it's not failing, like in our case, this may also be random. It's a random result, right? So it doesn't give you the right feedback. Doing things again, trying them again and again and again until they work or not work is another anti-pattern. It doesn't, for the same reason, it doesn't give you the right feedback. This has variations, this anti-pattern telling, it works on my machine, could you please try this on your machine? Could you please try this with a different JDK? Could you please try this with a different operating system? Just make sure it works. You will never be sure if you go that route. You need to have confidence, for a good reason, well-grounded confidence that what you have done is correct. What you have done is correct. Right? The code that we have done, that we have written so far, is correct. There may be an error in collect parallel, what the GPars team provides. Then send me an email and I'll send you the code. So, I'm part of that team as well. So possibly my fault if it's wrong. But you, as an application developer, should not be concerned with these details. Good. There is tons of information that is on the GPars homepage and that you can read through. There's a number of those fixed coordination schemes, like this one that we have done is fork join. There's also MapReduce that you can use just as easily, only with different method names. And then there's data flow, abstractions, and actors, and agents, and what have you. This is all, I'd say the main abstractions are very interesting to read about and to play with, and GPars and Groovy is a very easy way of getting your foot into this pool. Okay. We could go further for the last 12 minutes or so into parallelism. Would you like to see some really cool parallelism stuff? Yeah? Okay. Otherwise, I would have shown you the best piece of code that I've ever written. Okay, now go. Well, let's try. Let's see how long that takes. A really very interesting concept that is in GPars is the so-called Kanban flow pattern. Please allow me to show you an animation of that. And it is an animation, not a simulation, even though it possibly looks like a simulation. The difference is the animation, there's a real concurrency pattern behind it, and we only visualize it. It's not that we mimic the behavior, we are just visualizing the actual behavior. Also has a Gradle Starter, so they're starting the Gradle build. What it shows is one of the classical problems in concurrent programming, the concurrent producer-consumer scenario. You have multiple producers and multiple consumers, and they all work at the same time. Producer is producing something, here it fills up a battery with energy, and a consumer consumes whatever the producer has produced as a product concurrently. Now, if producer and consumer are kind of leveled in their timing, that's all nice and tidy. But this is normally not the case. Oh, that's not visible from the back. I can squeeze this a little, but not too much. Is that better? You can, or just come forward and we can stand around the projection if we want to. Good. So the one typical problem is the producer is rather fast, and the consumer is, did I do it correctly? Oh no, the other one. Consumer is slow, but the producer is fast. So what happens is, if there would only be no throttling mechanism of the producer would start producing like crazy, consuming all of your CPU time, filling up the internal buffer until there's no more buffer, and then stop. And then the consumer would start and would have too much to do. It's really bad leveling of resources. Instead, what we are doing here is the Kanban approach. Kanban says the producer is only allowed if he gets an indication from the consumer that he may produce. The Toyota production system had like little cards that they would give physically back and forth. Here we have like empty batteries that we give back. That means automatically all the processing power is consumed where it's needed at the bottleneck. Currently, the consumer is the bottleneck. Consumer gets all the resources in terms of computing time, and whenever he wants to do something, there's always a product before him in the queue. Now, what happens if, for some reason, producer slows down and the consumer is pretty fast? Then the empty batteries stack up in front of the bottleneck again, which is now the producer. Whenever the producer wants to produce, he always has the right to do so. Downstream, the whole system, the whole network of consumers that may be behind it, empties out. That means that the overall throughput of the whole system is exactly as fast as the bottleneck. This is the best that you can get, the best possible result that you can get. You always have automatically, without any intervention from the outside, the optimal throughput of the system. Now, so there is no central intelligence here that kind of optimizes the system. It optimizes itself. And by the way, the producer and the consumer alike, whenever they are finished, they can write into the next buffer in a non-blocking fashion. If you're into parallel programming and you have a system where you can write in a non-blocking fashion, that's the best that you can get. The buffer cannot possibly be any bigger than 6 because there's only 6 batteries in the system, right? Therefore, you can have a maximum number and you know you can always write into it. If you dimension the buffer as 6, you can always write in a non-blocking way. No synchronization needed whatsoever for the buffer. You can always write, you can always push on the stack, so to speak. Now, if for some reason you would like to have, you would like to throttle the system because all this concurrency makes you feel, you're a bit paranoid and you think there may be an error in it, so you can remove trace from the system. And by removing trace from the system, you're kind of limiting the amount of concurrency that goes on. I can even make the whole system a sequential system by removing the last but one tray. Now I have a sequential system, obviously. I can even stop the system by only removing the tray. Removing it, I've stopped the system. Not by stopping it from the outside as such. It's still waiting. It's waiting for something to do. But waiting it is not consuming any thread at this moment. There is no blocking thread. That's important. No blocking thread. Right? Because if you have no blocking threads and you have non-blocking writes, the system is deadlock-free by design. How cool is that? I do have goosebumps on my... So it is a very simple system, a very simple approach. The results are really amazing. When I came to the idea of approaching concurrency this way, or this very special problem this way, I thought, like, it cannot possibly be that nobody else has thought about this before. Actually, in the physical world, the Toyota production system and the logistics guys and the operations research and so on, they have all that, but it wasn't yet in software. So I did my very best of finding any prior art of this, and I couldn't find any. And I ask at every conference, and please, if anybody is aware of any prior art of this, please let me know. I'd like to refer some authoritative source saying, yes, this is a good way to do it. But until I get until there's more information. I claim originality on that one. I have even published a real pattern, a software pattern for this, Kanban flow pattern. You'll find it on the web. Under Google for Kanban flow pattern, you'll find it. And I'd like to see, especially there's some discussion going on in academia to really have some math behind it for finding good values of how much concurrency can go on in such a system and so on. It's difficult to find good measures of concurrency, really. By the way, we are talking Groovy, right? What you see here is Groovy. This is a Swing application where I have overwritten paint component, and all the rendering of all the various pieces is done in Groovy 60 times a second. The paint component is Groovy, right? And it's not even optimized. And it paints like almost 100 different images on top of each other for every paint, 60 times a second. Like the producer, for example, is an image, this label here. The battery is made of 3 different images for the background, for the inner fill, and for the lighting that you see on top, right? For the shining thing. These rounded rectangles are rectangles that are then overpainted by the other images. The light bulbs are also 3 different images on top of each other, and all these images are not pictures, not bitmaps. They are constructed from drawing primitives, right? So there's a gradient in there. There is a path where this is painted from. So that's about the performance of Groovy, right? You can do this 60 times a second, and you can have even, well, do it a bit quicker if you want to, right? So after a while, garbage collection sets in every now and then. Yeah, but this is how fast you can get. Would you like to see the code? Yeah? Ah, yeah, you don't believe me. Okay, I see it. So where is the show component? The show component has, well, it's all Groovy, as you see. This is the component that has the various, we call it sprites, that is objects that you can move around on a background buffer. We're creating the labels. Again, this is creating a label means returning a buffered image where the buffered image is made of, you know, font color renderer and setting the color and setting the font and all that stuff that you have to do in Swing. Show component with all the producers and consumers and what have you. And here's pin component. Now let me make this a little bit bigger. Oh, I cannot. For some reason it doesn't do it. But only for the general impression, that is about 100 lines of code, a little less. I have a draw transformed, and that means with a given graphics context, I'm drawing some buffered image, and I do a translation to a certain point in the system. And I start with these ones for the labels. Right? Draw transformed is a typical Groovy construction. It is a method that takes a closure that tells how to transform. We're doing this 60 times a second for every single element in the system. I'm keeping hold of the old transform. I construct a new affine transform. I transform it. I call the transformation over here. And then I restore the old settings for the graphics context and so on. That's plain Groovy. Okay. So that was kind of, and then there's, for example, for the trace sprites, when they move around, they have to switch around their orientation such that filling from green to red for the battery, the unfilling, the consuming of energy is the other way around, if you remember. So therefore, I have to, at some point, now time's up, I have to somehow switch it at some point in the system, and this is where it's done. If it is at a certain X range, then I simply move it around, right? I have to give it different coordinates. If it's inside, Shift F7, Alt F7. If there's a tray inside here, then I have to give this this glow outside, and otherwise I have to do it in a different angle. This is all affine transformations. Yeah, like so. So I would say we have a few minutes left for questions. Huh? Yes, please.
Does this pattern depend on the producer recycling batteries? So if the producer didn't need older batteries in generate new ones, will it still work?
The question, the consumer, the system here relies on always recycling the batteries. That's an environment-friendly solution, I would say. And that's the whole trick. If the producer would, like you suggested, produce new batteries, the whole system would break. That's no longer Kanban flow. The throttling mechanism that is behind it, that gives all the nice properties that we have seen, only comes from the consumer passing back some indication that the producer may now produce. You can think of it as a tray. When you go through airport security, you put all your stuff on the tray, but you cannot if there is no tray. Right? So the tray flows down the system, and some nice person from the TSA gives it back to you. Right? That's how it works. I most often call this a tray, really. And all the other approaches that I've seen for throttling the producer have subtle problems. For example, what you can have is a synchronous queue in GPars. You can queue up and have it synchronized such that it's like a strut between producer and consumer. But this may produce a traffic jam in your system. So it stacks up back and back and back and back until the beginning. So you have this kind of traffic jam possibly in the system. Whereas Kanban flow, you cannot possibly have a jam. Thanks a lot. Enjoy the conference. Keep grooving and make this day count.